Alright, welcome to 5.3 Slope. Yes, you were just sitting there watching a slug go across the screen. At some point you had to think to yourself, man, how fast is that slug going? How fast is he going there? Exactly right. Maybe a little too slow for what you're hoping, but that's what we're talking about. This whole section is talking about rate of change. So slope is essentially the idea of rate of change. How fast was this slug going? So let's take a look at that. Alright, so let's take a look at this slug problem here. So what I'd like to do is create a graph here showing the time it took for this slug to move. So this is going to be the distance from home, and this is going to be our y-axis here. It's how many feet from home is the slug, and I'm going to measure this over time in minutes. So that'll be my x-axis over here. So to kind of help me out here, let's get a little visual here. Let's think about a slug. When a slug travels, it leaves this nice trail of green slime here. So we can tell exactly where the slug has been, which is really nice for us. So think about this. This is the distance traveled from home over time. So I have 2 points already plotted here for you. This is like a little snapshot in time. Like I had my timer out, that's what I do in my free time. And I looked over and I said, okay, at the 4-minute marker since he left his home, where is he? Well, if you follow the graph over here, he is 3 feet away. So this is a point. After 4 minutes, he is 3 feet from home. So this is a point for us, which and hugely important. At 4 minutes, he is 3 feet away. So let's pretend, let's take this 3 feet, let's say, is just right about here. So here's 3 feet. And I'm going to put a little timer by that just so we can remember, yeah, I know after 4 minutes, that's where the slug was. Well, then I kind of got sidetracked and I wasn't paying attention, and the slug, he's going kind of slow. Later on, I look up and look at this. After what? At 9 minutes, the slug is what? This should be 7. So he is 7 feet from home. Woo, he's cruising. So at 9 minutes, he's 7 feet. So let's take a look. He's 7 feet, so that's maybe roughly here, the 7-foot marker. And I got a little timer to show you that says, oh yeah, that's when at 9 minutes he was there. So this is kind of how the slug is going, how he's leaving his home. So what I want to know is how fast is this slug going? So really what I'm looking at here is I'm looking at what is the slope of this line. If I can find the slope of this line, this is the rate of change or the speed. It's how fast is this slug moving. So you may be able to go from the picture up here. Really I'm saying, okay, how long did it take to go from point A to point B? From 3 foot to 7 foot. Well, we need to know a couple things. First of all, how far did he travel? Well, if you look at it, it's great. How far did he travel? Well, what has this got to be? It's got to be 4 feet. How do I know that? I just subtracted them. So let's look at our graph here. How does that relate to our graph? Well, check this out. I want to know how much did it change this way. What is this change in distance? From 7 foot to 3 foot is a what? It's a 4-foot change. Or you could just count it. 1, 2, 3, 4. He had a 4-foot rise. So that's awesome. Then I need to know his change in time. So now I'm looking at the x-axis right here. Over what time period did this change? Well, if I look at 9 minutes and 4 minutes, what's the difference there? Well, yeah, it's a 5-minute difference, and you're just subtracting them. Or can I count them this way? I'm going 1, 2, 3, 4, 5 minutes. So that is his change in time. So really, this is the slope of the line. So I'm saying, oh yeah, I can see how fast he goes. He's going 4 feet every 5 minutes. Wow. So how did we get that? Let's kind of formalize that a little bit. I said, first of all, oh yeah, he is at this difference between 7 foot and 3 foot. And I'm going to put that over time because it's a rate of change. So I'm going to say in the time change from what? 9 minutes and 4 minutes. So if I subtract these two, like I just did up on my picture, 7 minus 3 is 4, and this is 4 what? This is 4 feet. And 9 minus 4 is 5 minutes. So there's my rate of change. He travels 4 feet every 5 minutes. So that's how fast the slug's moving, 4 feet every 5 minutes. Or we say the slope of this line is 4/5. So that's rises 4, runs 5. That is slope. There it is right there. Excellent. So let's define this formally. Slope, the way we denote that, the way we represent that is with m. M represents slope. So there's a couple of different ways to do it. Really what we just looked at is we're looking at rate of change. We are actually looking at what? The change in y. These were my y values. So the change of y over the change of what? Over the change of x. So think about it. I looked at how much it is feet change, 4 feet, over how much it is x change, in this case time, how much does this time change? So change in y over change in x. Another way to write that is with these little triangles called delta. You may use these in science. You'll definitely use these in calculus. The change in y over the change in x. But really, the one you've probably seen before, or the one we're definitely going to use, is really rise over run. I want to know, how much did this thing rise? How much did it run? Well, it rose 4, it ran 5. And the way I kind of remember that, just to help me out, rise kind of sounds like y's. So y's are on top, rise, y's, kind of a little rough, but they kind of sound the same. And what's the run? It's y's over x's. So the run is the x, the rise is the y. Fantastic. And the most formal definition right here, boom, there it is. If I want to know how to plot, if I am given 2 points to find the slope, I use this right here. So this is kind of a fancy pants definition. Don't freak out. It's everything you just did. We just did it. We're just saying, okay, you have 2 points. So here are my 2 points that were given. We're going to call this one x1 comma y1. So that's the first point. And we're going to call this one x2 comma y2. So that's the second point. So what is this saying? You subtract your y's, just like we did, the difference in y's over the difference in x's. Subtract your x's. So we did y2 minus y1 over x2 minus x1. Fantastic. So that's slope. Let's do some problems. All right, let's try some skills of this. So we have given 2 points. We're going to find the slope of the line that goes through those 2 points. So I don't have to graph this one. If I have the formula, I can just straight up do it because I don't want to plot negative 20s way out there. So let's just use the formula. We're going to subtract. We can call this x1, y1. That's our first point. Call this our second point, x2, y2. And just follow the formula. We'll say, okay, m equals the slope of what? y2 is 4 minus y1, which is 16, all over what? x2, which is negative 20, minus x1, which is minus 12. So once we plug our numbers in there, go ahead and subtract them. So 4 minus 16 is negative 12. All over negative 20 minus 12 is negative 32. Then it'd be nice to reduce this a little bit. So I know a negative divided by negative is a positive. What's the biggest number that divides 12 and 32? Well, 4 goes into that 3 times. 4 goes into that 8 times. There is my slope, 3/8, or maybe 3 apples every 8 days or something. This is my slope right here of the line that goes through those 2 points. Awesome. Now I'd like you to pause it, try it, and then unpause it and see if your answer matches mine for these 2 points. Find the slope of the line that goes through those 2 points. Good luck. Alright, so here's the answer. And if you look at it, I have 2 answers. I have a green one and a red one. A big question now people always ask, does it matter what I call x1 and y1 and x2, y2? No, it doesn't matter which point you put first as long as you're consistent. So the first one I did, the first point here is x1, y1. And just be careful with your negative sign. Remember, negative really means plus. So if you go negative, that's plus 10, so you get 34, and you get negative 17ths. But what if I would have switched the order? What if I would have said instead of 24 minus negative 10, I would have done it the other way, negative 10 minus 24. It works as long as you're consistent on the bottom as well. So multiply those and check it out. I also get negative 17 over 2. So either way works out because you're just looking for the difference between the two. It doesn't matter which one you call x1, y1. Awesome. Let's take a look now at some other ways of seeing points. Alright, so let's take a look at these points. These are points in a table, so it's just in a table format. So don't freak out here. This is a list of points, and that first point is just 0, 3. I just put them in a nice table format, so we're okay with that. So again, this is all points. And the reason I want to look at them in this format, if I tell you these points are all on a line, so these are all points on a line, there's a couple of different ways to do it. And what's cool about this is, remember, we're looking for rise over run, or the change in y and the change in x. Can we find that change of y? If these are all points on the line, how much is it changing every time here on my y value? It changes what? From 3 to 7 is plus 4? 7 to 11 is plus 4. 11 to 15 is plus 4. Oh, it's going up plus 4 on the y's. What are my x's doing? Every time my x is going up by how much? 0, 1, 2, 3. I'm going up plus 1 every time. So if I can look at that, I can say, oh yeah, I know this slope. The slope of this line is y over x, the change in y, 4 over 1. Pretty cool, huh? Excellent. But if you didn't like that, you can always say these are just points. You can cover up your chart and just pick 2 points. Here are 2 points. Maybe you want to do it the old-fashioned, not the old-fashioned way, but if you want to do it like above, you can take the point 0, 3 and 1, 7. Pick any 2 points. They're all on the line, so it doesn't matter any 2 points. I just picked the first ones off there. So you could have said, sure, 7 minus 3, y2 minus y1 over 1 minus 0, and that will give me the same thing. 7 minus 3 is 4, 1 minus that is 4 over 1. So if you can see the pattern, that's great. If you don't see the pattern, just cover it up and move on to and use the 2 points from the table. Awesome. All right, let's take a look at another table here, and I'm going to look for see if I can find that rise over run pattern here. So is there a pattern in these points? Is there a pattern going on from 22 to 17 to 12 to 17? What is that? Yes, I'm losing 5 every time, right? Subtracting 5. So in this case, I'm losing something. Is there a pattern in my x's that I can see? It goes from -2 to 1 to 4 to 7. Aha. Yes, these are all increasing by 3. So if I look at the slope of this line, I can say, oh, I know what the slope is. My change in y is -5. My change in x is +3, so the slope of this is -5/3. So I can do it that way. Again, if you don't like to do it that way, if you can't see that pattern, no worries. Cover it up. You can pick the top point, whatever 2 points you want, the top one and the bottom one, or just take the first 2, however you do it, and then you can say, sure, I can still use my slope formula. I can say, let's mix it up this time. Let's say y2 is 22, so subtract your y's, because it's a change in y, 22 minus 17, and then subtract your x's, -2 minus 1. So if I do it this way, 22 minus 17 is 5. -2 minus 1 is -3. And again, these are the same thing. Doesn't matter if the negative's on the top or the bottom, or you can put it out in front. They're the same thing. -5/3 over is the same thing. That's still -5/3. So it works. If you can't see that pattern, go ahead and do that. How about the last one? Let's see if we can find the pattern here. So I got to look and be consistent. Is there a pattern here? Oh, it looks like it goes +6, then it goes +5. Oh, there's not a pattern here. So as soon as there's not a pattern, we've got issues. We can't do it. You can check over here, but it doesn't matter. No pattern there. And again, there's no pattern here. So this is not going to work our little pattern trick. So what do I have to do? I have to pick 2 of these points. So to pick any 2 points you want, I would use the bottom 2 myself. I would just say, hey, these are both positive, so I don't want to mess with these negative signs. So I'll pick these 2 points. They're all in the line. So now you have to use the slope formula. And let's subtract our y's. So I'm going to say y2, 17 minus 12. Subtract your y's over subtract your x's. And go ahead and subtract that out. 17 minus 12 is 5. 14 minus 4 is 10. Boom. I'm looking at 1/2 is the slope of that. Excellent. So those are the skills for finding slope using slope formula. Love it. All right. So we're good with looking at points. I want to look at more than just points. I want to do what's called the Vang. I'm going to look at this Vang. What is Vang? Vang reminds me of like Fang or vampires or vampire fangs or some kind of Twilight series something. No, it's not the teen heartthrob Edward. Vang is actually, this is how we're going to look at it. We're going to look at slope verbally, algebraically, numerically, and graphically. So we've just did numerically. That's looking at points and tables. I want to make sure we can do this all 4 ways. So when you understand and can tie these all 4 together, you've got a good understanding of slope and you'll be good to go. So let's take a look at each one of these individually. All right, so let's take a look at this verbally. Verbally means we're going to look at a little word problem or situation here. So Bob has 40 Skittles. He eats 5 Skittles every 3 minutes. So I'm looking for the slope, or really you got to think about it, rate of change here. I'm looking for the change. Is 40 the change? No, he starts with 40. That's not anything changing. That's a constant. Here's the change. He eats 5 Skittles every 3 minutes. So what's the slope in this case? Well, he's eating them. So if you want, you could think of this as a negative. He's losing what? 5 Skittles. He had 40. He loses 5 Skittles, so that would be a negative. 5 Skittles. How often does he lose them? He loses them every 3 minutes. So for it to be a rate of change, it has to be per or every. So these are key words right here, every or per. 5 Skittles every 3 minutes. If you want to write that just as -5/3, you could, but that's his slope or that's his rate of change. Awesome. Pause it, try to read the next little situation here and see if you can do the slope of that one. All right, hopefully you came up with 3 miles every 24 minutes. Again, the fact that she ran 5 miles already doesn't really matter for us. We're looking for the change, 3 miles every 24 minutes, or you could say 1 mile every 8 minutes. That would be great to reduce that. So there's your rate of change. Fantastic. So that's verbally. What about algebraically? Well, algebraically in this case is going to mean let's look at the equation. So we're going to talk more in depth about equations in the next section. But for now, I want you to be able to look at this equation and recognize where the slope is. The slope is the number in front of x. So for now, it's just saying, oh, I know what the slope is. It's the number right in front of x. In this case, the slope is 3/4. So maybe he gets $3 every 4 days or 3 pies every 4 hours. I don't know what it is, but it's the number in front of x. That's your slope. How about this one over here? So be careful. What's the number in front of x? Yeah, it's 2/5, but also take the sign. He's losing 2 every 5, so it's actually -2/5. So slope of this one's -2/5, number in front of x. He's losing $2 every 5 days or something. So that is the verbal algebraic. We already did numeric, so we've already done the van. Let's get the Vang. And we're going to end with the G, graphing. So looking at the graph. So this is great. So if I give you a graph, and we kind of started with the slug picture graph, what is the slope of this? And again, I like to think rise over run. What is the rise over run? So pick 2 points. It doesn't matter which two, as long as you go left to right, like I'm reading a book. So how is he rising? He's actually rising down 2 in this case. And how much is he running over? Well, he's running over 1, 2, 3, 4. So in this case, the slope is a rise of -2. You're going down 2, running 4. So down 2 over 4. And it's consistent over 2. I'm sorry, down 2 over 4. Down 2 over 4. That's always doing that same slope. Or if you want to reduce it to -1/2, you can. You go down 1 over 2, down 1 over 2. So that's the slope of the line. If you're more into using the points, you could definitely use the 2 points and the coordinates of these points. Pick any 2 points on here and say, oh yeah, this first point is what, -1, 2, 3, 4, up 1, 2, 3, 4. You could say one point is -4, 4. This other point right here is over 0, up 2. And again, you could use the slope formula. Once you have the coordinates, you can subtract your y values, subtract your x values, and you get -2 over +4. Remember, change. Negative minus the negative is like a positive. You still get -1/2. So if you really like using the coordinate points, go for it. So what are you going to do in number 2 here? Check this one out. There are no points. You got to put the points in. So you got to look to see, where does it exactly cross? Well, it crosses exactly here, right in the corner of these little boxes, these little grids. Looks like it crosses again here. Looks like it crosses again here. So you're making these spots where it's crossing exactly. So you have to fill in your own dots sometimes. Once you do, though, now do your rise over run. What is the change in y? What's it rising? Well, it's rising up 1, 2, 3, 4. And what's it running over? It's running over 1. So in this case, it's 4 over 1. And it's always got to be that, up 4 over 1, up 4 over 1. You can also go backwards. This has got to be what? It's got to be up 4 over 1 to get there, or it's got to be down 4 backwards 1. If you want to use coordinates like last one, you can, and then you'll be good to go. Excellent. So just to wrap it up graphically, a little bit more. So when we have slope, and I'm looking at a graph, so when I look at it, you're looking at it like you're reading a book, left to right. So as I go left to right of this thing, what is happening? Well, in this case, as I go left to right, I'm going downhill. Like, think of like a skier or a bike rider. You're going downhill, or this is a negative slope. So I want you to identify the slope of a line quickly. Boom. Left to right, that's going downhill. What about this? Aha, this one's going uphill. So what is this? This is a positive slope right here. It's going uphill from left to right. So think of a biker trying to bike up that hill. It's a positive slope. What about these special cases, though? We have 2 special cases. Look at the slope of this. What's the rate of change here? Well, it's not really rate of change. It's a constant. It's always 1, 2, 3, 4. It's always 4. It's never changing from 4. Maybe you always have $4. You're not gaining or losing those $4. Or think about this. What's the rise over run? Well, if I'm doing rise over run, how much am I rising up? Well, I'm rising up 0. I'm running over 1 every time. There is no rise, but there's a run. What's 0 divided by anything? Doesn't matter. If I have nothing divided by whatever you want, you get 0. So this actually has a slope of 0. So when you have a horizontal line, it's a slope of 0. So flat line horizontally, slope of 0. Fantastic. What about a vertical line, straight up and down? Well, check this out. If we're doing a slope of this, we're going to say rise over run. It's actually rising, isn't it? It's rising 1 every time, or whatever. What's it running? It's not running, though. So it's this vertical line. It's running 0 over. Now here's the problem. Can you take something divided by 0? If I have a candy bar, divide it into 0 parts, what does that mean? It's impossible. So what do we say for that? We say this is undefined. This is an impossible slope. So undefined is a vertical line. So when you have a vertical line, it's undefined. If you want help remembering that, here's what I always think of right here. Slope face right here. Let's check out slope face. These little lines here are eyebrows. So this eyebrow here is a line. What's the slope of this line? Well, it's positive. It's going uphill. It's a positive line. So I draw on this little eyeball here. That's a positive. What about this eyebrow? It's a negative eyebrow. This line is going down. The slope of this is negative. So the slope of this is negative. It almost looks like, it's winking at you now. Plus slope, negative slope. What about a vertical line? Here's his nose. What's the slope of this? Well, we need his nostrils. So to draw on his nostrils, we're going to draw on a U. What does that U stand for? That's right, undefined. So a vertical line, think of his nose, think of the U, it's undefined. And then what about a flat line for his mouth? Well, we got to put in his little dimples, right? Here's a dimple. Here's a dimple. So what's the slope of a horizontal line? Excellent. Just like this horizontal was a slope of 0, that's a 0. So slope face, I hope that helps you. I don't know, I just like drawing it. I think it's kind of cool. Positive line, negative line, vertical line's undefined, and horizontal line is slope of 0. Excellent. So, alright, slope. We can now ignore this danger sign. We're not going to keep away from slopes. We got them. We understand them. Look around. Slopes are everywhere. You know, the physical representation, there's a positive slope right there. If you look around, you can easily find examples of negative slopes. You're definitely going to see horizontal slopes or slopes of 0, and you're going to run into vertical slopes coming up right there. It is, which has an undefined slope, so it's vertical. But don't forget about really rate of change. Rate of change is in everything. It may not be a physical representation, but it's in everything that we do and everything that's out there. Whether you're looking at the stock market and seeing how it changes over time in a day, a month, or a year, or you're seeing how the amount of pressure affects an object, or if you're looking at projectile motion over time, or you're looking at the water level of a tub draining, or probably a pretty fun one is checking out a roller coaster. You've got acceleration, velocity, all kinds of rate of change going on there. But I think we can all agree that the most fun rate of change out there is going to be with the slug problem. Alright, good luck on the practice and the master check. I hope everything goes well. Peace out.